This is the fourth video lesson for Unit 6A. In this lesson, we will be predicting the products of a single replacement reaction. Let's go to page 19 in the class packet. Motivation: identify the reaction below, which are the single replacement reactions. If you recall, single replacement reactions have the pattern element plus compound gives you element plus compound. So take a moment to identify the single replacement reactions below. Here are the answers: reaction 1, reaction 4, and reaction 6. Notice they have the pattern element plus compound gives you element plus compound. So these are the single replacement reactions. Learning target. At the end of the lesson, I'll be able to identify if a single replacement reaction is spontaneous by using table J. Homework number 4 will be a Junopod based off this lesson. There will be a quiz Junopod based off PowerPoint 3 and 4. The exam will be on Unit 5C and 6A. Just to review, a single replacement reaction is when an element reacts with a compound, the element switches places with an element in the compound to form a different compound plus the element. Notice that element A replaces element B in the compound. So when a single replacement reaction is spontaneous, when the element A is more active or reactive than element B in the compound. However, if element A is less active than element B, then there's no reaction and the single replacement reaction is not spontaneous. So how do we know if A is more active than B? We look at table J. So this is table J. It's found on your reference table, so you don't have to memorize it. It's known as the activity series. It compares how reactive each element is relative to each other under aqueous conditions. You can only compare elements within the same column. For example, this is the metal column besides hydrogen, and these are the non-metals column. On top of the column is the most active. On the bottom of the column is the least active. Here is the activity series table from your textbook of the metals in aqueous conditions. So you can see that each metal is losing electron. The faster it does that, the more active the metal is. We will come back to oxidation reactions in Unit 14. There are 3 scenarios for single replacement reaction. The first scenario is halogen to halogen. Halogen is a group 17 element. In this chemical equation, I highlighted the halogen as red. Here we have sodium bromide reacting with chlorine to form sodium chloride and bromine. As you can see from this chemical equation, Cl is replacing the Br. So why does Cl replaces Br but not Na? Keep in mind, NaBr is an ionic compound. Na is positive, Br is negative. On the other side, NaCl is also an ionic compound. Na is positive, Cl is negative. So when Cl replaces Br, you're forming an ionic compound. If Cl was to replace Na, you won't form an ionic compound. The second scenario is metal to metal. I highlighted the metal as red in this chemical equation. Here we have sodium bromide reacting with lithium to form lithium bromide and sodium. Notice that the lithium replaces the sodium. Why does Li replaces Na instead of Br is the same reasoning as before. NaBr is an ionic compound. Na is positive, Br is negative, and the product LiBr is also an ionic compound. Li is positive, Br is negative. The third scenario is metal to hydrogen. In this chemical equation, I highlighted the metal and hydrogen as red. As you can see from this chemical equation, the lithium metal is replacing the hydrogen in this single replacement reaction. Check of understanding number 1. Why is it not possible to have a metal to halogen scenario? See below example. So here we have sodium bromide reacting chlorine. Chlorine is replacing the sodium in the chemical reaction. So why is it not possible? If you recall from the previous slide, we have an ionic compound and we have to form an ionic compound in the products. BrCl is not an ionic compound because it's 2 nonmetals. Therefore, there is no scenario in which a halogen will replace a metal. Check of understanding number 2. Explain why the student is incorrect. If we look at this chemical equation, potassium is replacing lithium in this chemical reaction. So this is a metal to metal scenario. So why is this student incorrect? Is because if you look at table J, lithium is higher than potassium, is more active. Therefore, potassium cannot replace lithium. Therefore, there's no reaction in this single replacement reaction. It is not spontaneous. So by looking at table J, we can see that lithium is more reactive than potassium. So lithium is the most reactive metal, and gold is the least reactive metal according to table J. And for nonmetals, fluorine is the most active, while iodine is the least active. Question 2. If you recall the trend for reactivity for metals, so that was on Unit 4, the periodic table trends, why is lithium the most reactive on table J? Shouldn't sodium and potassium be more reactive according to the trend? So the hint is think of the environment and factors. Table J, the activity series, is based on the aqueous, electrolyte, or acidic conditions. So this is going to play a role in the activity of the metals. If you recall, metals lose electrons, so they become a positive ion. To compare lithium and sodium, they're both positive 1. But sodium is a bigger ion than lithium, because sodium ion has one extra shell. So under aqueous conditions, water is going to form intramolecular forces with the ion. It's going to form molecule-ion interactions. When water forms intramolecular forces with the ion, it releases energy. The more energy it releases, the more favorable the interaction is. The more favorable the interaction, the faster the metal will lose electrons to become an ion, so it can form these more favorable interactions. It turns out lithium is more reactive than sodium because the interactions between water and lithium is much more favorable. It releases more energy than the interactions between water and sodium. So why is that? If you compare sodium ion with lithium ion, they both have the same charge, but lithium ion is smaller. So the same charge is more concentrated in lithium than it is with sodium. So the charge density is greater in lithium because the charge is more concentrated. So it forms more favorable interactions with water than sodium does. Learning check number 1. Which metal reacts spontaneously with nickel 2 chloride aqueous? Pause the video and resume once you complete it. Since the question is asking about a metal, which is an element reacting with a compound, this is a single replacement reaction. The metal is going to replace nickel in this chemical reaction. This is a metal-to-metal scenario, so how do we know if this reaction is spontaneous? We have to look at table J. The metal has to be more reactive than the nickel. By looking at table J, the metal has to be zinc. The answer is choice 4 because zinc is more active than nickel on table J. Let's do some analysis questions. Which chemistry reference table shows the reactivity of some elements? That will be table J. Question 2. According to reference table J, which metal is the most reactive? That will be lithium. The least active, that will be gold. According to reference table J, which nonmetal is the most reactive? That will be fluorine. And the least active will be iodine. Question 4. The only nonmetal found in the metals column is hydrogen. Organize the following elements from the most reactive to the least reactive based on table J. So here are the answers: aluminum, iron, and copper. So this is from most reactive to least reactive. For question 2, it is magnesium, aluminum, hydrogen, and silver. Magnesium is the most reactive, silver is the least reactive. Question 6. According to reference table J, which element below is the most reactive element? Since fluorine and lithium are on two different columns on table J, we cannot compare the two because fluorine will gain electrons while lithium will lose electrons, so we cannot determine this. So choice 3. Question 7. Magnesium metal reacts with hydrochloric acid, HCl. What are the products? Is it spontaneous? Write the equation. This is a single replacement reaction. Mg is reacting with HCl. It's a metal to hydrogen scenario, so the metal is going to replace hydrogen. So magnesium will bond with chlorine to form an ionic compound. To figure out the chemical formula between magnesium and chlorine, we have to use the crisscross method. So magnesium has a charge of +2, chlorine has a charge of -1. So we crisscross the charges, we get MgCl2. Hydrogen was displaced by the magnesium, and hydrogen is a diatomic element, so it will be H2. So the products are MgCl2 and hydrogen gas. Next, we have to balance the chemical equation. Notice we have 2 hydrogens and 2 Cl's on the product side, but we only have one of each on the reactant side. So we have to put a 2 in front of HCl. Now it is balanced, so is this reaction spontaneous? So we have to compare and contrast the reactivity between magnesium and hydrogen. If you look on table J, magnesium is more reactive than hydrogen. Therefore, this reaction is spontaneous. Question 8. This time, we have silver metal reacting with hydrochloric acid, HCl. What other products is it spontaneous? Write the equation. So we have silver reacting with HCl. This is a single replacement reaction. Silver is going to displace the hydrogen and bond with chlorine. So by using the crisscross method, you'll get silver chloride plus H2. H2 is a diatomic element, so it's always found in pair. So the products are silver chloride plus hydrogen. Now we have to balance the chemical equation because we have 2 hydrogens on one side, but we only have 1 hydrogen on the other side. Now the chemical equation is balanced, so is it spontaneous? So we have to check table J. Is silver more reactive than hydrogen? The answer is no. So there's no reaction because hydrogen is more reactive than silver. Learning check number 2. According to reference table J, which of these metals will react most readily with 1.0 molar of HCl to produce hydrogen gas? The unit molar is a unit of concentration. It is not relevant in answering this question. So pause the video and resume once you got the answer. So the answer is choice 4, potassium. The key word is most readily because calcium and barium will also react with HCl to form hydrogen gas, but K is the most active, the most reactive on table J compared to these elements. Therefore, it will be the most readily. Learning check number 3. Based on reference table J, which reaction would take place spontaneously? Pause the video and resume once completed. Since these are all single replacement reaction, you must look at table J. If the element is more reactive than the element in the compound, then it is spontaneous. The only one that has an element more reactive than the element in the compound is choice 2. If we look at table J, barium is more reactive than sodium. That's why barium will displace sodium in the chemical reaction. The other 3 will be no reaction. Learning check number 4. Based on reference table J, which metal will react spontaneously with AlCl3? Pause the video and resume once completed. In this single replacement reaction is a metal-to-metal scenario, so you're looking for a metal on table J that's more active than aluminum. So the answer is choice 4. Calcium is more active than aluminum. So calcium will displace aluminum in this single replacement reaction. For question 10, I want you to complete the table using reference table J, predict the products of each reaction, or write no reaction if it's not spontaneous. Pause the video and resume once you want to see the answers. So here are the answers. Number 11, read the following paragraph. Based on this information and your knowledge of science, where will you place platinum in the activity series shown on table J? You'll place it on the bottom because platinum is inactive, so you're expecting less reactivity, so it should be on the bottom of table J. Now work on numbers 12 to 17 on your own. Pause the video and resume once you complete it. Okay, so here's the answers. 12 is 4. 13 is 4. 14 is 3. 15 is 4. 16 is 4. 17 is 4. And for number 18, Based on reference table J, explain why silver would not react with HCl to generate hydrogen gas. The reason for that is because on table J, silver is below hydrogen. Silver is less active than hydrogen is. So this concludes the video lesson for today. Remember to do the Junipod homework and quiz.